So here, we're going to do the same thing basically we did with the arithmetic sequences on Friday. And we got our a sub n term right here for geometric, right, which just multiplies by a number, one less than the total amount of numbers that we have, right? And then we also have a formula to do the summing for the geometric formula. Okay, so two new, not two new formulas, but we're going to use these two formulas for today. And you will have these printed on the quiz at the top. So you don't have to worry about memorizing the formulas, but you have to know which one's arithmetic and which one's geometric, of course. But the formulas will be provided, okay? So just a little reminder that when you need to find the ratio, the way you actually determine it's geometric is that you divide any two ratios and you make sure it's consistent. So if I take these two and I do x to the third divided by x, or x to the 1, same thing, that comes out to x squared, right? And I should get the same exact answer no matter which two I pick, as long as they're consecutive, right? So if I pick those two, I'll get x squared as well. So that's how you first determine it's geometric if that needs to be done, right? So just review right there. And then just like before, we're going to have geometric means. So that means right here. So if you're given two numbers and told it's a geometric sequence or not, you could try it out. The numbers in between are called the means, right? So think of the missing means as missing numbers. Right, so we can find those whether they're arithmetic on Friday or geometric today. Okay? So let's see here. So let's see. We're going to use our a sub n formula to help us out. Right? We know everything except what r is. So you're using this formula and you're trying to figure out what r is. That's step 1. Step 2 is to apply r to the first term and check to actually make sure it works. Alright, so this is our a sub n, this is our a sub 1. And since we have 3 geometric means, we have 3 numbers in between here. That means altogether we have 5 numbers. Our n is going to be 5. So just to plug everything in there, I'll write out the formula first, like this. And it's n minus 1, yep. So we have 1. Actually, I put this backwards, huh? This is a sub 1, this is a sub n, because it's going down. So we're expecting our r to be a fraction, right? Since again, it's getting smaller, starting at 81, going to 1. And we'll have n minus 1, which is 5 minus 1, which equals 4. I just have to solve this equation. 81 times what number to the 4th power equals 1. All right, do a little solve. We got 1 over 81 is r to the 4th. And we're going to take the 4th root of both sides to solve that. Of course, that's the 4th root of the top and the 4th root of the bottom. Of course, the top would just be 1, because 1 times 1 times 1 times 1 is 1. And you might know this, what time the same number multiplied 4 times equals 81. What number is that? Yep, comes out to 3. Alright, so we've determined our r equals 1/3. Or, dividing by 3. Multiplying by 1/3 and dividing by 3. Alright, and then we can actually get the numbers now. So we got 81. 3 numbers. And if I divide 4 times, I should end up with 1. Alright, so multiply by 1/3, I get 27. Multiply by another 1/3, I get 9. Multiply by another 1/3, get 3. And these are the actual answers here, right? So we found our answers, 7, 9, and 3. And we can always do it one more time just to verify it works, right? So if I get all the way to the other end, and 3 divided by 3 truly equals the last number, then I know my R is 100% correct. Right? Now, fair warning on these, like on the quiz, this work is obviously mandatory, right? So you're not going to look at, well, I knew it was divided by 3, so do I still, like there's always someone that's still stuck in elementary school land. Do I still have to prove what I'm doing is true? Yes, it's always true. Write your work out, okay? Yes, question?
Why couldn't it be negative 432?
Try it. Negative, 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 negative. Does that work? We get negative 27 and negative 3. And unfortunately, means have to be in between.
Oh, yeah.
Yeah, so negative 27 and negative 3 are not in between those two numbers. But very good point. Very good point. So yeah, we have to leave it as a positive. And for that reason, usually I think in the books it actually says ratios are usually, but it's possible if we change the definition of that, maybe that would work. Interesting. Yep. Good, good, good. All right, try that out. You guys go. 4 geometric means between 3 and 3,072. All right. Okay. Be 48. 2, 7, 4, 8, 6. There we go. All right, so hopefully that went out well. Should have something like that. And also don't forget to actually say, your answers are actually the numbers inside. Okay. All right, almost done. Just going to do the sum formula. You'll see it down here. And we have a lot of minus ones and 1 minuses. Again, that comes from just when we're solving this, like all the n minus 1s, is that we have 6 terms, but you only have to bounce or multiply 1 less than that, right? 1, 2, 3, 4, 5 times with 6 terms. So that's why you get all these minus 1s everywhere when you start solving these and using these. So let's just practice that. Okay, it's right there. Of course, you have to figure out the ratio here. All right, it does say it's geometric, so I know it's going to be a ratio. So a couple ways of doing it, but you might be able to eyeball and just kind of tell what times what equals this, what times what equals this. Of course, in both cases, they're 1/2, so that's the ratio. If not, do what we did at the very beginning. All right, and you can just divide any 2 consecutive terms, and they'll come out to the same answer. All right, so if you weren't quite sure, you could always just say, well, what's 1/8 divided by 1/4? And then as soon as you solve that, you get 4/8, which equals 1/2. So either way, you can always find out what that ratio is. So let's plug it in, plug it in. We got 10 terms we're adding up. So I'm going to do S sub 10 equals, and let's get that formula on screen. There it is. So my first term is 1/2. So my first term and my ratio are the same. So we're going to have lots of 1/2s. All right, 1/2 to the n minus 1, which would be, no, it's just to the n. That's why. 10. There we go. All over 1 minus r. All right. So just do, again, a calculator would probably be nice to do that right here, the 1/2 to the 10th power. That'd be good to figure out. So 1 over 2 to the 10 is, plug it in, 1024. And then 1 minus a half, of course, is a half. And this is nice, right? Since the what's it called? R and the first term happen to be the same, they end up canceling out here. That's kind of cool. So now we're just left with 1 minus 1 over 1024. And we need a common denominator here, which of course is 1024. So 1 is the same as 1024 divided by 1024. Right? That equals 1. And we got common denominators, so we have 1024 minus 1 over 1024, which of course is 1023 over 1024. All right, so almost equal to 1, right? I want you to look at this and say, okay, that's what it is. You know, if it was 1024 over 1024, it'd be equal to exactly to 1. So this is basically 0.9999999, you know. And you can imagine if we took this and say, well, what about the 100th term? What if we did the 100th term? What would they add up then, right? You'll find that, well, we're just adding smaller and smaller fractions, and it never actually gets above 1. This will always stay less than 1. And that's starting to answer some calculus questions of like how far can you go to see what this thing equals. Like if you add up an infinite, right? If you can do something called an infinite series, and we added this not to 100, not to 1,000, but you know we keep going to a sub infinity. What will it actually end up to? Like, and you can actually find out. Well, if we added an infinite amount of times, what would happen, right? So that's kind of touching and brushing in on your calculus stuff, and what we're going to be looking at after the quiz, or next week, really. Kind of getting there and thinking about what happens when you just go down the road. Sometimes, you know, it converges to a number like this. It gets just close to 1. Sometimes it gets close to 0. Sometimes it gets infinitely big or infinitely small. So, pretty cool stuff. All right, so that's it. You got the homework on there, I believe? Yes? Okay. So you can get to work on that and, you know, get all the hard questions answered before you leave, if not all of them. And that way the rest of it is totally doable on your own.